So what did you just think about the video we just watched? It does look like they're having fun, okay? So a couple recommendations, okay? Um, I know you guys are a curious bunch. If you want to do that, please don't do it in your kitchen. That would be a bad idea. Bad idea, okay? Go outside, okay? Notice that the title is called Coke and Mentos, and you notice in the video they used Diet Coke, right? Diet Coke is better. Why? I don't care. It just is, right? I don't know, and I don't care. It just is, okay? If you haven't ever done it before, it's pretty cool, but it's not the sort of experiment I could afford us to do. See what I'm saying? Okay? We will be doing an experiment tomorrow, okay? So hopefully you'll be here because it's going to be fun and delicious. Okay? So, does it seem weird that I would show you that sort of video? Yeah? Right? But we are talking about Coke and Mentos today. Okay? A physics class hypothesized that dropping more Mentos into the bottle would create a higher stream of soda. The class conducted an experiment with several packages of the candy and 8 2-liter bottles of soda. The results are given in the table below. What do you notice about the table? Oh, there's some missing, right? Well, what it tells us right after the table is that the group who had 5 and 7 Mentos, they knocked over their Coke bottle before they could even measure it. Yeah, we all know people like that, yes? No names, no names. That's not nice. No staring, no pointing. Okay? But it happens though, right? In experiments, things like that happen, yes? So we're missing some data here for 5 and for 7. Is that like a problem, really? Maybe, maybe not, right? We want as much data as we can because usually more data gives us more information, yes? But let's go ahead and take what we're given in this table and let's make a scatter plot. Do you remember how to make a scatter plot? Can I remind you? Okay. So first of all, take your calculator out. It's quite difficult to make a scatter plot when your calculator is in your bag. Not saying it's impossible, I'm just saying it's difficult. And the next thing you need to do is, turn it on, right? Oh no, I accidentally turned it off. I need a new document. The document type that I need is, oh no, you can't even see it very well. Okay, a list and spreadsheet. That's what I need to start with, is a list and spreadsheet. Okay? If I get going too fast and I'm about to lose you, please stop me. I don't want to lose you here. Okay? Is everybody with me right now? You're still turning your calculator on? Oh, okay, you're good? Okay. So, what are we going to call this column right here? Yeah, Mentos would be a great title for this column, right? I mean, I suppose I could call it X, but that's boring. What do I put in this column? What do I enter here? 1, 2, 3. What now? 4. You want me to skip 5? Why would I skip 5? We don't have data for that, right? We have the number of Mentos that they use, but remember they knocked over their bottle, so I've got to go to 6, and then 8, right? Same thing for 7. They knocked over the bottle. We don't have data for that, okay? So what are we going to call this column? Height is a good name. Height. What are we going to put here? 6, 11, 14, 16, 20, and 22. Now, could we make some educated guesses before we go on? Could we make an educated guess about what 5 would be? What would it be? 18, like 18, it would be fine if that was linear, right? Is this linear? Everything goes up by exactly the same amount every time? No, it's not linear, but it's still not a bad guess to start with, right? Okay. What about 7 Mentos? 21 would be a pretty good guess, right? Again, that's kind of linear, and we know it's not linear, but it's a good place to start, isn't it? Good thing to think about, okay? So now that we have our data in there, let's look at what the graph looks like, okay? So we're going to say Control Doc to add a page. Control Doc. Everybody see where that is? This time we need to add a data and statistics page. Now remember, at this point in time, do our graphs look the same? No, and is that okay? Yes. When are they going to look the same? Yeah, I got to wake up my calculator. Where's my, there it is. There's my mouse. What am I going to add here? Click to add a variable. What variable goes here? Yeah, Mentos. That's our X value, right? That's the top part of our table. Mentos. Fancy. And then over here, we're going to click height. That's our Y value of our table. Now do they look the same? Yes, they should, right, if we put in all the same information. Okay? So first thing I want you to do is I want you to take your worksheet. I want you to look at this, what it says right here. It says make a scatter plot. We just did that. What characteristics of the graph indicate that a square root function would be a good model for this graph? Well, is it linear? Does it make a line? No, so I know it's not linear. It's suggesting to me that a square root function might make the best choice. Do you think a square root function would make the best choice? Yes? Okay, then why? Yeah, I totally agree with that. I totally agree that a square root function might make the best choice because it looks like one. Now, if we're given graphs, are we allowed to assume things about the graphs or the figures? No, we don't do that. We don't ever assume stuff, right? But it's asking us to guess, isn't it? Is it okay to guess by looking at it? Yes, it is. Okay? So I want us to go ahead and draw what this looks like. Something like that, right? Okay so far? Now we got to get a little mathy vocabulary-ish, right? Let h of x be the function that approximates the height of the spray in feet that results from dropping x Mentos into the Coke bottle. The rule for h of x can be written in the form h of x equals a times the square root of x, where a is a constant. Determine a value for a that fits the data and tell you how you found it. Okay? So let me zoom back in on my calculator so you can see it really clearly. Okay? How do you think we ought to go about doing that, finding the equation? Do you remember doing this before? Menu. Then what? Analyze. Then what? Regression. Menu, analyze, regression. Which one do I choose? What did we say it looked like? A square root function, right? So which one do I choose? Do you see the problem? It's not there, is it? So we have to go about this another way. I'm going to press escape. So I'm back at this menu. Everybody here? Menu, analyze, and we're here. I want us to choose 4 instead. I want us to choose plot function instead. Okay? So what it gives me is a place to guess again. Okay? Now, if I just put the square root of x in there, I can't even see it. It's there. I can't see it. Okay? Because it starts at 0, 0 and goes. And if you'll see how it's counting, it doesn't actually get down to 0, does it? Okay? So I need to double click on this. Uh-oh. Okay, sometimes it goes away. And when it does, just go back and find it. And this time I want to try, I don't know, what do you want to try as your A value this time? 20? We're just guessing, right? Is that it? No. What am I trying to get with this shape? As close to all the dots as possible, right? So what do I want to choose instead of 20? 10. So I double clicked on it. And what do you notice? It's closer, right? Take a couple minutes by yourself. First by yourself and then with your table group to see if you can figure out a good value for A. So take a couple minutes. Did you find a good one by yourself? Did you talk amongst your group? Are you all in agreement now of what you think might be a good A value? Tell me, what did you guys go with? What did you guys go with? Everybody did exactly 8. Did anybody try like 7.99 or 7.9 or 8.2? Would you try some of those real quick? See if they get any closer? I'm not judging you. I'm just asking. Are you good? Did you find one? All right, what'd you guys go with? 7.8? What about you guys? What'd you go with? I'm going to take a commercial break real quick. We're taking a commercial break. Is there a right or wrong answer to this question? No, we're guessing. We want to get as close to as possible to every one of these dots with our square root curve, but your opinion as to what's close as possible versus my opinion might be slightly different. Will one of us say 8 and one of us say 10? No, there's a right or wrong answer there, isn't there? Okay, because this is 10 that's on the board right now, and we know that's not right. Right? It's not even touching any of them. Okay? So please know we're free in here to answer questions. Even if we get it wrong, we can always make corrections, right? Okay? So what did you guys go with? Oh, back to the show. What'd you go with? 7.9? What'd you guys go with? 8.5? Kenna, what'd you guys go with? 7.9, right? That seems like a lot of you put that, so I'm going to go ahead and put 7.9. Let's look at it. Seven 7.9 versus 8. Versus 7.95. What do you want to settle on? 7.95, that's what you want to settle on? Is everybody okay with that? Is everybody okay with the fact that it doesn't touch this dot at all? The only way to make it touch that dot would be like 6, right? And if I put in 6, is it touching any of these up here? No. Okay. So do you want it to be 8? What do you want it to be? I can change it easily. You know that. 7.9? Is that where we're going with? Okay. So let's write that down on our paper. Let me zoom back out real quick. So we're going to use h of x equals 7.9 root x. That's the equation that us as a group are going to do the rest of the worksheet with. Okay? If you're curious, both of the class periods before you chose different numbers than you, and they chose different numbers than each other. Right? Do you see the point I'm trying to make? We can still get the same general types of answers even if this number is slightly different. You okay with that? Okay. And tell how you found it. How did we figure this out? We did what? We used the calculator? I just didn't hear what you said. The scatter plot, so we used the scatter plot in the calculator and? It's exactly what we did, isn't it? We used the calculator and we guessed. If we're going to guess, we're going to be honest about guessing. Yes? Okay. Okay so far? Any questions? Okay, so let's go to the back. With your value for A, use your function to estimate the height of the spray for x equals 5 and x equals 7 mentos. So what I'm actually trying to find is h, whoops, ignore that part, h of 5, isn't it? Well, what do I write down if I'm trying to find h of 5? 7.9 square root of 5, exactly right. So I'm going to add a page that's a calculator on my calculator, and I'm going to say 7.9 root 5. What did you get when you did that? Let's do 4 decimal places today, because why not? What do you get? 6 what? 49? That's a rounded number, right? So, but it answers what we put into the calculator. Now, would you please answer the question? Estimate the height of the spray for x equals 5. So you want to say 17.6 feet? I'm okay with that. No, I'm actually not okay with that. Can we fix it? Yes, thank you. 17.7 feet? That's correctly rounded though, isn't it? Okay. What if somebody would have said 17.66 feet? Would I be okay with that? Yeah. What if somebody would have said 18 feet? Would I be okay with that? Why am I okay with all those different answers? It says estimate, right? It doesn't say what level to estimate to, but it does say estimate. So all of those answers are correct, aren't they? Okay. Now think back to a minute ago when we said, what do we think 5 might be? We started with 18 and said it'd probably be somewhere near 18, right? Haha. That's near 18, isn't it? Good, we were right. Now let's find h of 7. How do we find h of 7? Very good. 7.9 root 7. And what'd you get? Now would you answer the question for me? 21.9 feet would be appropriate. What else would be appropriate? 21 feet would be appropriate. 20.90 would be appropriate, right? Think back to what we said we thought it might be. 21. Haha. With your function rule, estimate how high the soda would shoot out of the bottle if you used 10 Mentos. What's it asking us to find? So H of 10, exactly what we just did. Why isn't it a different question then? Why didn't they put it in the same question? What's true about these two values? They were mess ups, right? They were mistakes. Well, what's true about this value? Yeah, they didn't even do it. They stopped at 8, right? They stopped at 8. So we're predicting really how high this would be, right? Okay. We're still estimating though. So we're going to do 7.9 root 10. And when we put 7.9 root 10 in our calculator, what do we get? 24 point, what'd you say? 982. Now I did ask you to go to 4 decimal places. Why did you just go here? Oh, it's 199, right? So for the record, if I ask you to go to 4, we got to go to 4, even if it's a 0. I'm not mad. Does that make sense? Okay. So let's answer the question now. What do you want me to write? 25 feet. I'm okay with that. What else would I be okay with? 24.99. Yes. Would I be okay with 24.9? No, because that's not correct rounding, is it? Okay. All right, number 4. Using your function rule, set up and solve an inequality to determine the number of Mentos you would have to use for the spray to go at least 30 feet in the air. So I'm going to use my function rule because it says using your function rule. But I need to set up and solve an inequality that has something to do with 30. What does it have to do with 30? At least 30 feet, right? So what has to be true about how high it can go? Can it go 31 feet? Can it go 29 feet? No, it needs to be at least 30 feet. So what symbol goes right here? Very good. Greater than or equal to. Okay? So how do I go about solving this inequality? Probably want to isolate the radical, right? So let's divide both sides by 7.9. The square root of x is greater than or equal to, let's see, 30 divided by 7.9. 3.7975? Is that what you got? How do I undo a square root? So if I square both sides, x is greater than or equal to 14.4208. Yes? This answers the inequality. What answers the question? We're solving for the number of Mentos, right? Can you have part of a Mentos? Part of a Mento? Part of a Mentos? I don't even know how to say that. Can you have part of a candy? You can, right? Is that logical in the situation? Then what should we write as our answer? Why do I write 15 Mentos instead of 14 Mentos? It takes more than 14. Now, logically, mathematically, does this round to 15? It does not, right? It's 0.4. It does not round to 15. But if I put in 14, 14 is not greater than or equal to 14.4208, is it? Okay. Everybody okay with that? Okay. Last question. Using your function rules, set up and solve an equation. Okay, so we got an equation this time to estimate the number of mentos required for a spray to reach at least 50 feet. So what is that equation going to look like? 7.9 root x equals 50. How do I solve this? So divide both sides by 7.9. Good. Root x equals, whoops, 6.3291. Is that what you got? And then to undo a square root, square both sides. X equals 7 what? 7? Good. That answers the equation. What answers the question? Will 40 mentos get us to exactly 50? Will 41 mentos get us to exactly 50? No. So what are we going to write as our answer? Yeah, you can't get exactly 50 unless you use partial mentos, can you? Okay, do we want to use partial mentos? Not really, so what should we write? Okay, now you have homework, okay, and it's the last two parts of question number 5. This question right here and this question right here. Do you think this is reasonable? Why or why not? No. It's homework. It's homework. Is 41 mentos reasonable? Yes, ma'am. Okay, is 41 mentos reasonable? That's what it's asking. Got it?